Now that we've done the 2025 differentiation exam, let's do the integration exam for 2025. This is level 3 calculus, apply integration methods and solving problems. And again, I'll be using everything's in the formula sheet, especially these formulae here. And I'll be using this calculator, which is the most common calculator. There'll be times where I'll just give the answer straight away rather than watching you painstakingly put the numbers in. But if we need to use it, then it's all well and good. All right. So with that, let's do it to it. Question 1 starts us off pretty slowly. We have 6x, we integrate 6 secant, 3x, 10, 3x dx. Okay, let's take 6 front, secant, 3x, 10 x. Now I'm going to put here's U substitution, I think. U is going to be equal to 3x. du x is going to be equal to 3. Therefore, dx is going to be equal to du over 3. So we're going to divide everything this way. So this is going to be 2 because it's divided by 3. Secant u 10 u du. Now this is already up here. Then we differentiate as we get this. So integrate this the other way, we get secant. So it's going to be 2 secant of u, and it's going to be 3x. And don't forget the c. So far, so good. In this one, we are given a differential equation dy dx. It's 3 square root of x plus 2 over the square root of x. And given the initial condition, y equals 10 and x equals 4. So we're going to need to find c is. So let's difference it. And I don't like those records floating around. So I'm just going to say 3x to the power of half plus 2x negative half. I'm going to multiply both sides by dx. So x is going to go here. And it's going to go there. And then I'm going to take both sides. So integral of dy is y. So that's no. The integral of 3x to the half is 3x to the 3 over 2 divided by 3 over 2 plus 2x to the positive half now divided by half plus c. Let's clean this up a little bit. 3 divided by 2 over 3 is 2. X to the 3 over 2 plus 4. 2 divided by half is 4. X to the power of half plus c. Know that y equals 10, x equals 4. So 10 equals 4 to the power of 3. 2 plus 4. Square root of 4 is 2. 8. So it's 2. 4 to the power of 3 over 2. I don't know if I'm casting this in Mr. Casio. 2. It's 8 times 2 is 16. So 10 equals 16. It's 8. C. So therefore C must be equal to 10 minus 16 minus 8, which is minus 14. So our full equation is y equals 2x power 2 plus 4 power minus 14. And there is again using the power rules later than using. The next one gives us these numbers here, and then we're told algebra integral equals a, but there's an here, and this is also an so determine the possible values of a. So I can think of a couple of ways of doing it. Either we could integrate this to find a and then put it in there. Right? Well, let's integrate this one first. And they tell us that a is constants. So 2 over 1 a minus 6k is negative 2 equals 3. So the first thing we need to do is work out what this would be if we just ignored the 2 and 1. So kx minus 2 is going to be minus and 6k will stay where it is. So add 1 and we'll have to divide that by negative 1, which will make this a positive. And once we've done that, we can set that equal to 3. Can we solve it? Oh, we can put the 2 and 1 in there. Right, let's do that. I've sort of had a look at it, sort of know how I'm going to solve it. Let's put in 2 in here. So the first one is going to have 2a just k over 2x and negative 1 is over x minus, if x is 1, minus a plus 6k, just 6k is yes, equals 3. All right, that's it. Let's see. Let's combine these. So I've got 2a plus 6k over 2 minus, I think that's as far as we're going to go with it. 2a minus a is a plus 3k minus 3k. 3k minus 6k is minus 3k equals 3. And I think this is as far as we're going to go, as far as that's concerned. But let's go right back to the beginning. Get this thing here. So ki6. Try to the beginning that 1k on 6x dx equals 1k 6x dx. So let's work it out. First thing we've got to do is do the indefinite integral. 6x dx is going to be 6 squared with 2. So it's going to be 3x squared plus c, but it's going to be using the definite integral add-ons. So a is going to be equal to k squared. There we go. So now we can substitute this one here and this one here. We can add them together. We can sort of merge them. So 3k squared minus 3 minus 3k minus another 3 equals 0. Now we have quadratic equation. So we've got 3k squared, 3k minus 6 equals 0. Now we have very, very nice quadratic equation. I'm going to divide all sides everything by 3. So k squared minus k minus 2 equals 0. We want to do is convert that to k plus 1 equals 0. So k can be to -1 or positive 2. Now, are there any things on here? No, it just says that the constant are the same, positive constants. So here's our answer. K can be either -1 or positive 2. On to question D. This one is quite an involved one. We're shown a curve here, and the area under the curve is what we want to work out. Give us this function. So the function is this beast here, and it is from 0 to 6. And they want us to find the area of the curve. It's sine 5x times cos 3x times 4. So rather than integration by parts, let's use a trig identity. It's sine times cos, so we're going to use sine of something times cos of something. We can use this one here. So 2 sine A cos of B, that is sine A plus B plus sine of A minus B. So A is going to be 5x, B is going to be 3x. So this is going to be sine of 8x plus sine of, and we head to a halving problem. That's here, this 2 here. So it ruins things for us. All right. But there is a 4 in the front here. There is a 4 in the front here. So if I was to rewrite this, I'm going to write 4 up half sine of x plus half sine of 2x, which is going to be 2 sine of x plus 2 sine of 2. So that's in a really nice form that we can now integrate. So let's integrate it like not integrating by parts, but integrating piece by piece. So I'm going to differentiate, so integrate that. 2 sine of x. I'm going to let u be equal to x. And when I do that, it's really nice. Equals 8. So therefore, the x is going to equal the u over 8. Later, when I do it with 2, u equals 2 of x. Dx is going to be equal to u over 2. I don't really like doing that, so I probably may need to use this again. Here's v. Just so we don't get our u's and anything else. I probably won't come back to lines at all. Okay, what does that mean? That means that we should rewrite this. It is 2 over 8, which is a quarter, negative cosine, and we convert it back, So this is going to be equal to negative 1 over 4 cosine. That's the first half. Second half is going to be very similar. So we've got the 2 out the front. We integrate this sine with respect to b, and sine b dv, and it's going to be divided by 2. So it's going to be 1 minus cosine. So 1 times minus cosine, and the b is. So now we have something we can work with. So we have minus 1 over 4 cos of ax. Plus and minus is minus cosine of, we want all of that between 0 and pi over 6. Let's put all of our exits into this. We're going to need to find 4 things here. The tempting thing is just to put that height and just ignore the 0. And I would say don't do that. So negative cosine of 8 pi over 6. So first one, grab your calculator, make sure it's in radian mode. So cosine of 8 pi over 6. That. Divide that by 4 is that, and we want to convert this to positive because there's a negative sign, so it's going to be 0.18. That's the first one. The second one is going to be negative cos 2 times pi over 6. It's 2 pi 6, which you should say pi over 3. Calculator. Negative cosine of 3. I put the negative sign in there already. Negative 0.5. Okay, then we need to do the zeros. So negative cosine of 0 divided by 4. Well, cosine of 0 is 1. So this is going to be negative 1 over 4, which is negative 0.25. We put it in the decimal. Conversely here, it's just by itself. So cosine, negative cosine 0 is negative 1. Okay. Now remember, it's the first 2 added together minus the second 2 together. So we're going to add picture. So the grand total is going to be 0.125 minus 0.5 minus 0.25 minus. So in other words, 0.25 minus 0.5 plus 0.25 plus 1. And it's going to give us, remember, that 0.125 minus 0. Plus, because remember it's minus and minus, 0.25 plus 1 is that. It's very familiar, 0.875, because I think that is yes, it is a common factor, and 7 over 8. So there, 7. Fantastic, all of that, just for that. This next question gave some students nightmares. It's a little bit tricky, I admit, but it is an excellent question. All right, so we're given the differential equation y minus xy, so our x and y is not going to be easily separated, minus brackets 1 plus x, close brackets, dy dx equals 0. Okay. This is a separable equation. There are a couple of more advanced ways of solving it quicker. I'm going to solve it using what a year 13 should know. So first thing, I hate this 0 here, so I'm going to take it over to the other side. So y minus xy is going to be equal to 1 plus x dy dx. That 0 is got missing now. Now on the left-hand side, we see a really good way to get rid of one of those y's. Let's factorize it. So y is 1 minus, which is brilliant for us. All right. Now this is the step that a lot of people, and before we even start differentiating and integrating, is what we're going to do. We're going to divide both sides by 1 plus x. So y 1 minus x plus x. Now I know that these have really, really nice qualities that we can exploit. Okay, what I'm going to do now, I'm going to multiply both sides. I want all the y's over one side and all the x's over the other side. So without sort of doing it by just by looking at it, I'm going to take you through the steps. So I'm going to multiply both sides by dx. So y minus x plus x. Multiply that by dx, and we have dy. Then I'm going to divide both sides by y. So this y is going to disappear, and I'm going to divide that by y, and that's going to be 1 over y dy equals 1 minus x plus x dx. Now, see, all the y's and all the dy's are on one side, all the x's and all the dx's are on the other side. Now, can we integrate? Yes, we can. Let's integrate this left-hand side first. It looks pretty easy. So we integrate 1 over y dy. Sometimes you can see it. You often see it written like that. I prefer this method. So I don't messing with. And I know that that's going to be the natural log of, it's supposed to be the natural log of the absolute value, but it's going to be in brackets for now. Okay, that's the left-hand side done. The right-hand side is the right-hand side. In that form there, I can't really do an awful lot with it. So what I'm going to do, I'm going to use long division to do this one. Sorry, just think what I was thinking. Yes, I am using long division. I think there's a couple of ways we could do it. We could add and subtract an x onto the top. I'm just going to go long division. So at the bottom here, I have negative x plus 1. So plus x plus 1 there. Okay, how many times does positive x go into negative x? Well, it goes in negative 1 time. Now, x we take away. X plus 1 times that. So we take away minus x minus 1 there. So minus x minus minus is plus x. So they go 1 minus minus, and that gives us a big old 2. So we can rewrite this as 2 over x plus 1 minus 1, which was this is really, really good for us because now there isn't an x at the top. There is only an x at the bottom. And if we wanted to, we could bring that to, so let's click up what we've got and see what, when I integrate that now, so this here, that is going to be 2, 1x plus 1, isn't it? That's really, really good. So let's begin integrating this side. So I bring the constant out front, 1 over x plus 1 dx minus on that side here. Now I'm going to let u be equal to x plus 1. I want to change sides. The good thing about that is du dx equals 1. So that means du equals dx, which is really, really great for us because now I can transform that to 2 u negative 1, which is 1 over u, the u minus 1 dx. Now we're cooking with gas. Okay, so 2, 1 over u with respect to u, minus integrate 1 with respect to x. As long as you don't mix them up, we're fine. So this is going to be equal to natural log of u. We'll integrate negative 1, we get x, and we have to have constant term. And the constant term is just the constant term from this side and the other side. Add all the constant terms together, we collect it up in one space. But we didn't start with the u. U is just a crazy thing we out. So the answer is going to be 2 natural log and u is x plus 1. It's terrible. Plus 1 minus x plus c, and it's flipped up the left hand side. So that's what we've got. After all of that, we have those. Now we need to find out what c is. And they do give us an initial condition. The initial condition is y equals 3 when x equals 0. So the natural log of 3 is going to be equal to 2 natural log, and x is 2 natural log of 3, yes, minus 2 plus c. I don't have it right. I remember in the beginning, x is 0. When y equals 3, x equals 0. So 0 plus 1, 2 is x. Okay. 2 times minus 0. More zeros. Right. Fantastic. Because that tells me that the natural log of 3 is a number. Now, the natural log of 1 is 0. So 2 times 0 is 0. Minus 0 plus c. So therefore c must be natural log of brilliant. Now our equation is as such. Natural log of y is going to be 2 natural log x plus 1 minus x plus natural log of 3. But we're not done. Don't wait, there's more. We want to find, this is where I got confused. We want to find y with x equals 2. So, all of this, natural log of y, let's work out all of this right hand side. 2 natural log of 3 minus 2 plus the natural log. Okay, so that means that there are 3 natural log of 3 minus 2. Bring this 3 out top here, so the natural log of 3 times 3 times 3 is 27 minus. Now we want to get rid of this LE, so we exponentiate it. So y is going to be equal to e to the natural log of 27 minus 2. And about exponents, this is going to be anything. It's going to be 27 over e of a minus b, e to the a, e to the natural log. There we go. Here is our final answer. This is not a very nice question, nor was it a really nice answer. But on to question 2. So the standard integration. Let's do ourselves some hand here by bringing this 10 out front. X plus 1 6 x. And let's this u substitution. So let's let u be equal to 2x plus 1 du dx is going to be 2, which means that du is 2 dx. If we want to change it to u, we need to divide everything by 2, which is going to get that. So we'll write this as 5. And I'm going to write u minus 6. Change variables. Sign up. Yes, I think. Okay. So I'm trying to get rid of the integral signs. We have 5 times u to the minus 5 divided by minus 5 plus c. So this 5 is going to go away. We can move to a negative. We can move to minus 5 plus c. So our answer is going to be minus 2x plus 1 to the minus 5 plus c. And I guess we could rewrite this as minus 1 over 2x plus 1 to positive 5 c. We can do that question. In this question, we're told that the rate of change of a particular function p, I guess it's function t, that is given by dp dt is 5 cosine of 4t, and we're told the initial condition that when p was 8, t equals pi over 4. They want us to solve the equation, its final form. Okay, so we've got dp dt, 5 cosine of, so therefore p is going to be equal to 5 cosine of u substitution. I'm not going to use double angles or anything like that. I'm just going to say that u be equal to 4t du dt is therefore going to be equal to 4. Therefore, du is going to be equal to 4 dt, so we have to take this 4. So it's going to be 5 over 4 cos of u du. Right. When we integrate cos of u, we get sine of it. So it's going to be 5 over 4 sine u plus c now. We didn't start with u, we started with 14, so P is going to be 5 over 4 sine of 4t plus some constant. Now we're told the initial conditions. P equals 8, T equals pi over, okay, we'll set that equal to 8, pi over 4, okay, 5, now 4, so 6, I guess, plus C. So this way, 5 over 4, brackets, yes, so brackets like that. 0.625. I see, therefore C must be equal to minus 0.625. Like me, so it's going to be 7.37. We're done. Okay, next question. Right, our next one, students seem to hate these questions. You're not given the thing you're looking for in the actual equation that's up here in the limits. This, we're looking for K. So, how do we go about doing that? Let's integrate this thing straight away. Going to rewrite this x and type that equals 1. Okay, well, it's pretty easy to find out. You shouldn't use going to be equal to 4x plus 1, and that means that du dx is going to equal to 4, and that means that dx, at the end here, we can substitute with du over and substitute that. So it's going to be u, let's move back a bit. So when we come to integrate this fully now, it's a quarter, u stays there, gain a power, but we also have to divide by, don't worry about the plus c at this stage, because ultimately we're going to be doing, okay, so when we divide by 2, we're going to be multiplying by 2, which means that this is going to be half. Yeah, 2 times a quarter is half, yes. U and the quarter goes, yes. So that's what we've got there. Never mind my talking away to myself here. And 4x plus 1, because I didn't do the same. And I think that's, okay, so that's the indefinite bit done. Now we need to do these limits. So 0 to k of this equals 1. So in other words, half x plus 1, 0 to k, k test. So half of 4k plus 1, which on 0 is 0 plus 1 is 1, is 1. Square root of 1 is. So let's open this. Let's multiply everything by 2. This half is a piece that's done to. So 4k plus 1 half minus 1 equals 2. Yeah, that looks a lot better. Okay, so let's get rid of this 1. So 4k plus 1 half equals 3. Let's see it's starting to come together. Now let's square both sides. So 4k plus 1, anything to the power of half squared equals 8 to the power of 1 equals 3 squared, which is 9. Now we're almost done. Take 1 away, so 4k equals 8, divide both sides by 1, must equal So there's our final answer. It's sort of thing around there, but the answer will come out. And I suspect no matter how you go about it, the answer will eventually pop out. Yeah, good question. Physics students should be familiar with this type of question. We're told that a particle's acceleration can be modeled by this, where acceleration is a function of time. It is the acceleration in the particle in meters per second. T is the time in seconds. Run start timing. Initially at point P, particle had a velocity of 6 meters per second. How far from the point P is the particle 3 seconds after timing? So we're finding displacement. This one, it's a physics term, meaning the distance from initial starting point. Not the distance covered, but displacement. Okay. So if we imagine a sort of a point here P, so a line where P, our little particle is moving in that direction and it passes this, it's moving at 6 meters per second. Okay, good. Now we want to know when time is 3 seconds, how far have we moved? And displacement is an S of T. They do it in physics in S because D of T is obviously taken. So S, I think, is in the German word also means the same as displacement. Could be right, I'm not sure. Check me up on that in the comments. But we use this. All right, so let's look at what we've got and what we're given. What we're looking for. So ultimately, we want to find S3, don't we? S after 3 seconds of displacement. All right, and we're given that the acceleration at some time is 2.4 e, is every e minus 0.3 t minus 1. It's going to be back to 1 and that's it. Okay, we know though that the velocity of something, when we take the integral of the acceleration with respect to time. So when we integrate, then it's 2.4 e to the minus 0.3 t minus 1 with respect to time. We are going to get, if you remember, we have some number here, some other number here, time. We integrate that, we get, remember. So we're going to get 2.4 divided by negative 0.3 e to the negative 0. And this 1 also has to be integrated. It's going to be 1t, and we're going to have a constant. I'm going to have to integrate this again. So I'm going to put a C1 there to show that's the first constant. And then we need to work out what that first constant is, and this is the velocity with respect to time. What velocity is a function of time. Okay, let's simplify this a little bit. 2.4 divided by 0.3, 2.4 divided by negative 0.3 equals negative 8. So negative 8 e to the negative 0.3 t minus t plus c1. And we're told that the initial velocity when t equals 0, so that's vt equals that. We're told that v 0 is equal to 6. So minus 8e 0.3 times 0 minus 0 plus c1. Okay. And that equals, what is that? Minus e to the power of 0.3 times 0 zeros. So that's minus 8 minus 0 plus c. So therefore c1 must be equal to 8 plus 6 plus 8, which is 14. So there we go. So now we have the full, it's going to be minus 8 e, e's not up there, it's down here, e to the minus 0.3 t minus t plus 14. Okay, so now we know that when we integrate velocity with respect to time, we get the displacement, and that's what we're actually so let's take this and blame our ruler. So to minus 8 divided by minus 0.8 e minus 0.3b minus t squared 4/2 plus 14 t, that we get something now, plus 2 second constant. I don't really like this business up here. So minus 8 divided by minus 8.3 equals 26 and 2/3. They're going to give me because 18 over 3 then to the minus 0.3 t plus minus t squared over 2 is 14t plus c 0. And then the question, can we find c0? Initially at point B, so eventually imagine when t equals 0, we're at the fixed point. So in other words, when time equals 0, p equals 0 as well. So 0 is going to be equal to 80 over 3 e to the power of minus 0 squared over 2 as 0 plus 14 times 0, which is 0 plus c2. This is going to be e to the 0 as 1, which is 80 over 3. So c2 is itself 80 over 3. So now we have enough for the entire 80 over 3 e negative 0.3 t squared over 2 plus 14t plus 80 over 3. Fantastic. But is that the final answer that we need? How far is it? 3 seconds afterwards. Okay, so easy. A, 3. E. Now, 0.3 times 3. 3 times 3 is negative 0.9. It's 3 squared over 2 plus 14 3 plus 80 over 3. Okay, now we grab our calculators again. Okay, I'm going to put the 80 over 3 in brackets because the kids have calculators. E to the negative 0.4 is that, so that's 10. Okay, minus 902, which is 4.5. 902 is 4.5 plus 14 times 3 plus, there's some brackets as well, 18 over 3 is 5. Where did I go wrong? I had to go there. I put plus 80. 3, it should be minus 3. Ooh, lucky. Can we do that? 5. 80 3 e to the negative 0 close brackets is that minus 3 squared is 9 over 2, so that's 4.5 plus 14 times 3 is that minus 18 over 3 is 21.675. 21.67, actually 21.7. Like it's plus C, but then it's minus. Okay, that's the answer. So 21.7 what? The distance. Oh, thank goodness for that. So another little trick that I'll show you here is quite separate. When we want to integrate something which has something up front, you may have it B, to the B, X, Bx. When we come to integrate it, it's going to be A over B, E to the Bx. I see. It's just a nifty little trick which helps me quite a bit to shortcut different problems rather than messing around. This question looks like a zoo, and it is a bit of a zoo. But if you know your trick identities, you should be okay. Y equals sine cubed of x times cos cubed of y. Now there, I don't know. Now, if we have a look at this, if we break it down and use this little step here, I'm going to try to get rid of, and the reason why I do that is when I integrate it, it's not going to give me negatives. Okay. So cos squared plus sine some number is going to be equal to, it's going to be equal to 1. Okay, we can rearrange that so that cos squared is going to be equal to 1 minus squared. of x squared of x plus sine squared of x equals 1. So I'm going to take the minus sine x across. Now, cos cubed is just cos of x times by cos of x. Okay, so cos squared of x and both of those are things. Now, this is going to be very, very useful because I know what's going to happen to this cos x at the end when I come to change formula. So it's between 0 and something over. At the moment, we've got 0 pi over 2 on one extreme, sine cubed of x cos cubed x. And I know that little trick that cos squared of x is equal to 1 minus sine squared of x. Okay, fair enough. Now, we want to do a new substitution. I'm going to let u be equal to sine x. And you see why I chose sine of x, particularly when I put this positive x by itself. Let's rub that out. We'll do it a little bit. Continue this a little bit later. So I'm going to rewrite that with this involved. So this is 0, 2, sine cubed of x, and then 1 minus sine squared of x. So there, close brackets, cos dx. That's all we've got so far. So I am going to let u be equal to sine. Now, when I differentiate u with respect to x, differentiate this with respect to x, I get cos. So therefore, the u is equal to cos of x. Exactly what we've got here. Is that clever? So we can replace them. We can replace these u's where these sines and x's and u's with u's. So we need to change the inner and outer angle. So sine of 0 when we apply u, sine of 0 is sine of pi over 2 is, now we can rewrite this. This all looks like magic in these bits. Integral calculus is magic. 0, 1. Look up here, sine cubed of x is just u cubed. Sine squared x is u squared. U. All the signs changed, and now we're good to go. So let's expand that bracket. So 0, 1, u cubed minus u to the fifth. Send out all those brackets. Now we want to integrate this. So it's going to be u to the power of 4 over 0 over by 0 over 4 minus u to the power of 6 over 6. We don't need a c because we've got integrals. Okay, so now let's work it out. So let's work out when u equals 1. So 1 to the power of 4 is 1 minus 1 to the power of 6 is 1 over 6 minus 0 in there. 0 to the power of 4 is 0 divided by 4 is 0. 0 to the power of 6 is 0. So we don't worry about that at all. Now the winner is 1/4 minus 6. So let's put these over power, a common power, so they're all common power 12. So it's going to be 3 over 12 minus 2 over 12. Now what is 1/4? That's our answer. The word of those x's, we completely change a variable by putting the old numbers into that variable. All of these u's will contain the information that we previously put into them. We didn't just do a hocus pocus magical trick. They put all the information into this u and get the same answer. Good question. It really stumped quite a few questions, quite a few candidates. If you didn't know what to do, would have been more at C, and that's always good if you want to really test the students who know what they're doing. Good question. Now we get to question 3. Question 3 asks us to use numerical methods to estimate. In this case, it's area. This was the method that was required before calculus was formally invented by Leibniz and Newton. It's also used today for irregular shapes like quantity surveyors. It's a very, very, very important skill, very valuable skill if you want to work out how much stuff someone is. So they want us to use the trapezium rule. So there's a hole which has been dug into the earth here, and they want to know the cross area using the trapezium rule. So the trapezium rule is half h y0 plus, so it's the first y plus the last one plus 2 of the other lengths, bracket, close bracket. So for this one here, it's going to be half. Now what is h? H is the distance between these points, and it's a good an even one. So half times 5 times h1 is 2.12. The last one is 1.8 plus 2 close brackets, so it's like brackets inside bracket. The first one is 2.32. The second one is 2.65. The third one in there is 2.54. Close brackets, close big brackets. Work it out. So half times 5 is going to be 2.5. Now we grab the calculator. Oh, there we go. So 2.5, 2.12 plus 1.88 plus 2 times brackets 2.32 plus 2.65 plus 0.54 close brackets. If I miss any, 6532 1.88 2.12 half times 5 is 2.5 yeah 47.55 47 5 and it's meters, all lengths in meters, and I just want cross section, so it's 15 meters squared, and that's that. That's that done. There is a method as well called Simpson's method. Sometimes they can use it. They tend to be fairly similar. But again, in the olden days, this is how they had to find things out. And the fact that it is a way of doing it now. Instead of measuring 5 meters, they would just put a laser across and it would be a range finder, and they'd find hundreds of measurements and be more accurate. And now another one where the limits is what we're trying to find out. We're trying to find out what A is, finding out in terms of K. Okay, so each one the answer in terms of K, and K must be greater than 1. Which relates to the let's start. I'm going to take the 10 out the front. K, X is the X so far. Alright, I'm going to do my substitution always works. So du dx is going to be equal to 2. So du over 2 dx. That means that 10 AI is 1 over 2 times u over 2, and we get to multiply it by half. So it's going to be 5 k over 1 u times 2. Let's integrate this one side, integrate this u minus 1 du, we weigh that there. And that's going to be log of, we don't need to break out the c because it's a definite integral, so yes, we're fine with that. Okay, so this is going to be 5 natural log u plus c. You don't need to worry about plus c. We soon start with u, so we're going to go back to 5 natural log 2x minus 1, evaluated between 1 and a. So let's put those numbers in. So 5 natural log of 2k minus 1 minus 5 natural log thesis of a. Natural log of 2 times 1 is 2 minus 1 is 1. It's going to be interesting because we know that the natural log of 1 is 0. So this is going to be 5, and that natural log here, 2k is 1 minus 0. Can we simplify that anymore? Why is it doing that? So because it says show terms of k. Yeah, that's as simple as we can get. So that would be final answer. It's that 0. Okay. Yeah, another nice question. So here's a differential equation in lots of different terms. Probably the quickest way I can see a way to do that. 2 using calculus. I'm just going to use it by separation. So we've got dy x is square root of 4y plus 1 all over x squared. We want all of our y's and the dy's on one side, and the x's and the x's and the dy's, all the y's on one side, all the x's on the other side. I'm going to be able to cross multiply because I'm going to be able to cross those over. So I'm going to be left with dy doing sense, dy plus 1. It's going to be equal to x over x squared. Just cross them over. And I don't really like having those forms. So I'm going to transform all y to the negative 2. It's going to be equal to x negative 2 x. And for me, I can just run out the no less form here. I don't really like it. Of course, this looks prime for integration at this stage, isn't it? We've got all the y's and dy with x and dx, so let's do our magical integration suit. I'm going to do the left-hand side up to one-hand side here. All right, here on the right-hand side. So integrate x negative 2 x to gain 1, so it's going to be x to the power of negative 1, and then we're going to need to divide by negative 1, which is negative x to negative 1. So that's what it is. And there's going to be a plus there. I'm only going to put a plus there over this side, but I integrate on this side a plus c, but I'm going to sort of we're going to collect all of the constants into one single constant. If we can avoid it, we don't want different constants running around the old constant, so we can combine. Okay, going to this left-hand side. So what I'm going to do, I'm going to make the obvious u substitution. U is 4y plus 1, and that tells me that du, dy is going to be equal to 1. So that tells me u is going to be equal to dy is going to be equal to du over 4. And then if we come to rewrite this, it's going to be u to the power of negative 1 du over 4. That's going to be great. So that means when we integrate this, we're going to get u to the power positive half divided by half times 1 quarter, aren't we? Yes. And when we put the u back in, we're going to get 4y plus 1 to the power of half. And it's all going to be half times 4 is 2 plus c, but the c that I put there, we're going to add it to the c, so we get one single c at the end. So now that we've done all of the integration, let's collect up terms. So we've got in brackets 4y plus 1 to the power half, and that's 2 square root over 2 it's going to be equal to negative x to negative 1 plus c. Okay, so far so good. And what do we want to do now? We want to put in the initial condition. So the initial conditions are when y equals 2, x equals 2 over 3. So y equals 2, let's do the same thing. And y equals 2, x equals over 3. Okay, so 4 times plus 1 square root, minus this and minus the square root here, over 2 equals negative, and 2 over 3 to the power of negative 1 is 3 over 2 plus c. So let's work this out. So this is 4 times 2 is 8 plus 1 is 9, square root of 9 is 3. So 3 over 2 equals negative 3 over 2 plus c. So therefore c must be equal to 3 over 2 plus 3 over 2, which is 6 over 2, which is so our complete subject now is going to be y 2 is going to be equal to 1 plus 3. We're not quite done yet. Now we need to know what y equals when x equals 4 over 5. So x equals 4 over. Well, let's just copy this down here. 4y plus 1 to the power of. It's going to be equal to negative 4 over 5 to the power of negative 1 is 5 over 4 plus 3. So negative 5 over 4 plus 3, you have no idea what that is. So 3 negative 5 over 3 negative 9. Always put brackets here. 5 over 4, 7 over 4, 1.75. Oops, that should be over 2. 1.75. Okay. It tells us if we multiply both sides by 2, and we get 4y plus 1 square root, and 2 times 1.75, 3.5. Now let's square both sides, take 1 away from that, and we should get that number minus 1, 45 over 16, and it's going to be 2.8125. So y equals 2.8125, and I think it's a fraction 45 over 16. Another really nice little questions. More involved, get the playing around, see if we can get a nice test of your knowledge there. I like it. And in this question, we're asked to solve for p. No, not really bring us to prove this. Given this p here and 2p in the curve, so the area p of the curve there is equal to 9 over 4 units. All right, so let's set this up. So p to 2p of x squared plus 6 over x to the power of 4 dx is going to be equal to 9 over. Now this x squared plus 6 over x to the power of 4 I don't really like it, so I'm going to distribute it a little bit. Okay, I'm just going to separate out those functions, and it's going to give me x to the power of -2, and it's going to give me 6x to the -1. It's a lot easier to work with. So drawing up again, here it is. So we have b x minus 2 minus 6 x to the minus 1. So far, so good. If we ignore that p and sp, we're going to get x minus 1 divided by -1, which is negative x. Negative x plus 6x to the -3 divided by -3. It's going to change things around. The 6 and the -3 are going to cancel. We're going to be left with 2, and it's going to become negative. Let's go. So now, when we evaluate, we're going to over x minus x cubed evaluated between p to p, we get 9. Okay, now what do we want? Well, let's apply these numbers. So let's break it here. Substitute p in. It's going to be, we're going to put 2p in first. So -1 over 2p minus 2 over 2p cubed minus 1 over p minus 2 over p. And it's going to be equal to 9 over 4. So when we come to rewrite this, this is going to be equal to negative 2 over p, negative 2 over 1 over 8, 2 cubed is 8, p cubed, plus 1 over p plus minus 2 over p cubed equals 9 over 4. And that 2 there is making my life a bit funny. So what I'm going to do, I'm going to simplify. Can simplify. Sure. Yes. All right. So now let's collect up all the terms that have the same denominator. So we have 1 over p minus 1 over 2p, and that's going to be the same as 2 over 2p. This one by 2 over 2, which is 1, minus 1 over 2p. They have the same denominator, therefore it's 1 over 2p. So it's done and it's done. Yeah. And now let's do the other one. So 2 over p cubed minus 1 over 4 p cubed. We want to multiply top and bottom of this first one by 4 over 4, which is 4 over 4. multiply the 4 each one. So really we multiply by 1. Then we get 8 over 4b cubed minus 1 over 4b cubed. They have the same denominator. So we get 7 over 4b cubed. And now we combine them. 1 over 2p plus 7 over 4p cubed equals 9 over 4. Almost there. Almost there. We want it to look like 3p cubed minus 2p squared minus 7 equals 0. We're nearly there. Nearly there. Now, we are going to multiply all of these terms. So we get 4p cubed over 2p plus 7 times 4p cubed over 4p cubed. It's equal to cubed. And for this, so this is going to it's going to go, it's going to go to 2. That's going to go, that's going to go to 2. It's going to cancel it. And the 4's here. Cancel because it's 9 times 4 times p cubed. So after all of that, we've got 2 p squared plus 7. My bad, this should be a 9. Write it down. So yeah, right. Plus 7 equals 9 p cubed. And it's almost in this format. We take 2p squared, take 7, left with 0. That's one. And that's what we wanted. About this bit, it was a 9 the whole time. Sort of looked at it for a few more seconds. I copied that down. But that's our answer, and that's where we wanted to get. QED. Mistakes happen in maths, just be really careful. And if you see something, always Murray is planning to hang a piece. Murray is planning on hanging a piece of this art on the wall. Okay? This is shown on the diagram below. Curve here informs this. There. The equation of the curved form is f of x is 1/3 brackets x squared plus 3 brackets r squared. Murray has researched a way to make the picture balance by using the following formula. The x position, where he can hang it, I guess this is where it puts the whole dangles it from the puts the hole and things are there, so it's going to balance perfectly. As given by that one there, we need to find what the x value is. Okay, the upper part of it goes 3 over x times that function, and the lower part is 0 to 3 of this original function. So we've got quite a bit of work to do, and first of all I'm going to do is I'm going to get rid of this messy function. So I'm going to get it as one polynomial. So x squared plus 3 x squared plus 3 is x to the 4 plus 3x squared plus 3x squared plus So the bottom function is going to be 1/3 x to the power of 4 plus 6x squared plus 9. And I'm going to actually put this 1/3 through the rest of the equation. So the bottom bit is going to be x to the power of 4 over 3 plus 2x squared. 6 times 1/3 is 2 plus. So that's our fx. Let's go down the bottom. Okay, so this is our original f of x. The one to go at the top, we're just going to multiply them by. So this is going to go. So I keep a track. So it's going to be x to the power of 5 over 3 plus 2x cubed plus 3x. Don't need to worry about the c because we're finding the function. So this is the top function that we get. Right, having said that, let's integrate. Let's do that. The top one first. So we want 0 x to the power of 3 plus 2x cubed plus 3x respect to x. So let's ignore the 0 and the 3 to begin with. So we have x to the power of 6 divided by 6, 0 to 3 there, so 18 will come down the bottom, plus 2x stays, the x stays, we get a 4, therefore we get a 4, therefore this cancels, this can go to 2, and this last one is 3x stays there, it gets a 2, and we divide by 2. Now we want to put in 3 and 0. So we're going to get 3 to the power of 6 divided by 18 plus 3 to the power of 4 by 2 plus 3 times 3 to the power of 3 over 2 minus 0 to the power of 6 over 18. So 0 minus 0 to the power of 4 divided by 2 is 0. 3 times 0 squared is 0. So that's going to be 0. So all of the action is going to be, I'll do them 2 by 2. So 3 to the power of 6. This piece here, divide that by 18, 40.5. 3 to the power of 4, I should not. 3 to the power of 4, there's a 1, divided by 2, more, 2 there. 40.5 as well. 40 minus 3 times 3 squared is 9 over 3 times 9 is 27 over 2 divided by 2. It's 13.5. So all of those added up gives us our top number. So 45 plus 40.5 plus 13.5, that's us 94.5. Right, now we're cooking gas. Now we need to integrate this bottom one. What are the x? What are the x over 3 2x squared plus 3. Integrate this one between 0, ignoring the 0 and 3. It gives x to the power of 5 divided by 5, but there's already 5 there, so there's a thing, plus 2x cubed over 3 plus x, whatever plus in terms, because it's a function. So we want to evaluate this function. We want to evaluate that between 0 and so that's going to be 3 to the power of 5 divided by 15 plus 2 times 3 over 3. 3 times 3 is 9. These actually x equals 0. There would be 0, so we just have to do 3 to the power of 5. 2 is 43. Divide that by 15. 16.2. 3 cubed is 27. It's 2. It's there. Divide that by 3. 18. Plus 9. Add them together. 16.2 plus 18 plus 9. Is that 43.2? We're not done, because that's the denominator, and the numerator was 94.5. So the x we're looking for is 94.5 divided by 43.2, and it's 94.5, yes, 43.2. And our final answer is going to be divided by 0.3. It's 2.1675. It's our answer. I like that answer. So 2.175. So I guess that means that there's some things that somewhere along that dotted line, the center curve to there. And it'll be level. Let's see here the exam. So the questions in this exam, they're not totally impossible. There's just a lot of scribbling to get. But, I mean, it is a level 3 calculus exam. So, now, what are you going to do about it? I hope you enjoyed that. Subscribe, like, share, all you want. I don't mind. Fantastic.